The global automotive landscape is currently trembling under the weight of a revelation that most of the world has yet to fully comprehend, because we are standing at the absolute precipice of a shift so monumental that it threatens to render every existing electric vehicle on the road today a relic of a bygone era. For over a decade, the narrative has been dominated by a frantic race between manufacturers to shave a few minutes off charging times or add a few miles to the total range, but these incremental gains have always been held back by a fundamental wall of physics that many believed was impassable until this very moment. However, the silence in the industry has recently been shattered by news emerging from the inner sanctums of CATL, a company that does not just participate in the battery market but effectively dictates its heartbeat and overall direction through sheer industrial dominance. To understand why this news has sent a shockwave through the boardrooms of every major car manufacturer, from the high-tech corridors of Silicon Valley to the historic industrial hubs of Germany and Japan, you must first understand that CATL is the hidden backbone of the entire green energy transition. This is the entity that provides the lifeblood for the world's most recognizable electric vehicles, and when they announce a breakthrough in solid-state battery technology, it is not merely a corporate update but a declaration of a new world order in transportation. Imagine for a moment the psychological liberation of an electric vehicle owner who no longer has to harbor a subconscious fear of battery fires or the agonizing wait at a charging station that feels like an eternity compared to the quick stop at a petrol pump. We are talking about a transition where the liquid core of the battery, which has been both the greatest strength and the most dangerous weakness of modern EVs, is replaced by a solid architecture that promises to rewrite the laws of energy density and safety. Simultaneously, this shift is so profound that it makes the current battle between brands like Tesla and BYD look like a minor skirmish before a total tectonic reorganization of power that will determine who survives the next half-century of human mobility. Many people mistakenly believe that the true innovation in this industry happens in the design studios of car companies, where sleek lines and massive touchscreens are born, but the reality is that the real control is held by those who master the chemistry within the cells. A car can have the most advanced self-driving software and the most luxurious interior, but if the battery is heavy, slow to charge, and prone to degradation over time, the entire product remains a compromise that many consumers are still hesitant to embrace. CATL has played its hand with masterful precision by focusing not just on the theoretical science of the laboratory but on the brutal and unforgiving reality of global manufacturing scale, which is exactly why their move into solid-state technology is viewed with such intense trepidation by their competitors. While many startups have spent years showcasing impressive prototypes that never see the light of day, CATL possesses the industrial muscle and the existing supply chain to turn a scientific breakthrough into a mass-produced reality that could hit the streets sooner than anyone anticipated. This is why the world's most powerful automotive CEOs are suddenly choosing their words with extreme caution, because they realize that if CATL successfully sets the next global standard for battery architecture, every existing production line and every multi-billion-dollar investment in traditional lithium-ion technology could be at risk of becoming a stranded asset. The era of the liquid-filled battery, which was adapted from the small-scale needs of laptops and smartphones, is reaching its absolute limit, and the transition to a solid-state future represents the first true evolution of the electric vehicle since its modern inception. As we peel back the layers of this development, we see a company that has moved from being a simple supplier to becoming the ultimate gatekeeper of the industry's future, and their latest move is designed to ensure that no matter who builds the car, the power that drives it will belong to them. This is not just about a better battery, it is about the total subversion of the traditional automotive power structure and the birth of a technology that will finally force the internal combustion engine into the history books once and for all. The tension is palpable because the stakes have never been higher, and the revelation of what this technology actually does under the hood is about to change everything you thought you knew about the limitations of electric travel. To truly appreciate the magnitude of what is happening, we have to look at the origins of CATL itself, a company that did not exist in the public consciousness a decade ago but now sits at the center of a global energy war. They are not just making batteries, they are making the future possible, and their latest solid-state announcement is the final piece of a puzzle they have been building for years. Every major automaker, from Mercedes-Benz to Hyundai and from Honda to BMW, has integrated CATL's technology into their most prestigious models, which means the entire industry is now tethered to CATL's innovation cycle. If CATL moves towards solid-state technology, the rest of the world has no choice but to follow or risk becoming obsolete in a market that moves at the speed of light. This is the story of how one company decided to stop following the rules of physics and started writing their own, and why the giants of the industry like Elon Musk and the leaders of BYD are watching more closely than they are willing to admit the transition from liquid to solid. Is not just a technical change, it is a total transformation of the user experience where the car becomes more efficient, lighter, and safer than any petrol-powered vehicle could ever hope to be. This is why when CATL speaks, the entire world stops to listen, because they are the only ones with the power to turn a laboratory dream into a global reality that you will soon find in your own driveway. The hidden limitations of today's technology are about to be exposed, and the solutions that CATL is bringing to the table are more radical than anything we have seen in our lifetime. As we dive deeper into the mechanics of this revolution, you will begin to understand why the old guard of the automotive world is so terrified of what comes next. The power balance is shifting, and the throne is no longer occupied by those who make the cars, but by those who control the energy that moves them, and CATL is making it very clear that they have no intention of letting that control slip through their fingers. By the time this video concludes, you will see exactly why this is the most important technological breakthrough of the 21st century, and why the end of the petrol era is much closer than the critics would have you believe. Every second of this narrative is leading to a final revelation that will show you exactly how the world's most powerful companies are secretly preparing for a future that they once thought was impossible, and why you as a consumer are about to witness the greatest upgrade in the history of human transport. Beneath the polished chrome and the high-definition displays of the modern electric vehicle lies a volatile and aging secret that the industry has spent billions trying to mask through clever engineering and sophisticated thermal management systems. To truly grasp the magnitude of CATL's breakthrough, you must first look into the dark heart of the current lithium-ion battery, which, despite its revolutionary impact on our smartphones and laptops, is fundamentally ill-equipped for the brutal demands of high-performance transportation. The core vulnerability of every EV on the road today is its liquid electrolyte, a flammable chemical soup that serves as the medium for energy transfer but also acts as a potential detonator waiting for the right conditions to trigger a catastrophe. This liquid core is the reason why a minor accident or a manufacturing defect can lead to thermal runaway, a terrifying chain reaction where the internal temperature of a battery cell spikes uncontrollably and ignites its neighbors, creating a self-sustaining inferno that defies traditional firefighting methods. While car manufacturers boast about safety ratings and reinforced battery cages, the physics of the liquid electrolyte remains an inherent liability that forces engineers to sacrifice efficiency for safety, creating a heavy and over-engineered shell that adds hundreds of kilograms to the vehicle's weight. This weight is a parasitic tax on performance because every extra pound of protection requires more energy to move, which in turn demands a larger battery, creating a vicious cycle of inefficiency that has haunted the EV industry since its inception. Furthermore, the liquid nature of these batteries makes them incredibly sensitive to the very thing they need most, which is rapid energy intake. When you plug a modern EV into a high-powered charger, the internal resistance of the liquid electrolyte generates immense heat, and if you push it too hard, you risk creating microscopic crystalline structures known as dendrites that can pierce the internal separator and cause a dead short. This is why, despite the promise of lightning-fast charging, your vehicle's onboard computer is constantly fighting a battle to slow down the flow of electricity to protect the cells from self-destruction, leaving you tethered to a charging station while the rest of the world moves on. This limitation is what gives birth to charging anxiety, a psychological barrier that has kept millions of potential buyers loyal to the internal combustion engine, because they simply cannot reconcile a 40-minute wait with the 3-minute convenience of a petrol pump. But the problems don't stop at safety and speed, because the liquid electrolyte is also the primary driver of battery degradation, where the chemical structure of the cell begins to break down from the very first day of use. Every time you charge and discharge your car, the liquid medium undergoes a subtle but irreversible chemical change, losing its ability to transport ions efficiently, which is why an EV that can travel 500 kilometers today might only manage 400 after a few years of heavy use. This looming threat of a massive replacement cost hangs over the second-hand car market like a dark cloud, effectively destroying the resale value of electric vehicles and making them a risky investment for the average consumer. Enter the solid-state revolution led by the giants at CATL, where the flammable liquid is completely purged from the system and replaced by a high-density solid material that fundamentally alters the battery's behavior under stress. By removing the liquid, CATL has effectively deleted the possibility of thermal runaway, because there is no longer a volatile medium to ignite, which means the massive heavy cooling systems and reinforced steel enclosures that plague current EV designs can be stripped away. This is not just a safety upgrade, it is an architectural liberation that allows for a battery pack that is lighter, more compact, and capable of storing twice the energy in the same physical footprint. When you eliminate the fear of fire, you also eliminate the need to throttle charging speeds, allowing for a direct and uninhibited flow of energy that could finally bring the EV charging experience into parity with the traditional gas station visit. This technological leap is the bridge between the niche market of early adopters and the mass market reality of global electrification, where the electric car is no longer a compromise but a superior machine in every measurable category. The industry knows that the liquid electrolyte battery has reached its theoretical ceiling, and that any further improvements will be marginal at best, which is why the transition to solid-state is not just a choice but a survival mandate for the giants of the automotive world. As CATL moves to mass-produce these solid architectures, they are essentially providing a solution to every major criticism that has been leveled against electric vehicles for the past 2 decades. We are talking about a future where your car is not just a gadget on wheels but a stable high-performance energy storage device that retains its value for decades rather than years. The stakes are incredibly high because the company that masters the solid-state interface first will not just lead the market, they will own the entire ecosystem of human movement, and the silent tension we see in the industry today is the sound of 1,000 engineers realizing that the old rules no longer apply. The death of the liquid battery is the birth of the true electric age, and the revelation of how CATL is solving the manufacturing hurdles that have stopped every other company in their tracks is the final piece of a puzzle that will leave the competition in a state of permanent shock. The true tragedy of the modern technological era is that we have been promised the miracle of solid-state batteries for nearly 2 decades, yet every single announcement has ended in the graveyard of laboratory prototypes and failed startups that could never translate a scientific breakthrough into a physical product on a factory floor. For years, the narrative surrounding solid-state technology was one of perpetual delay, where brilliant researchers could demonstrate a single cell working perfectly in a climate-controlled room, but the moment they tried to scale that process to produce millions of units, the entire chemistry collapsed under the weight of manufacturing reality. This is precisely where the story of CATL diverges from every other pretender to the throne, because they are not approaching this as a scientific curiosity but as a brutal exercise in industrial dominance. To understand why CATL is different, you must realize that the biggest hurdle in solid-state chemistry isn't just making the ions move through a solid medium, but doing so while maintaining a perfect interface between the materials over thousands of charge cycles without the battery cracking or delaminating. In a liquid battery, the fluid naturally fills every gap and maintains contact with the electrodes, but in a solid system, the materials must be pressed together with such immense precision and consistent pressure that even a microscopic air pocket can cause the entire system to fail. Most companies have been defeated by this interface problem, finding that their solid electrolytes are either too brittle to survive the vibrations of a moving car or too expensive to manufacture at a price point that any normal human could afford. CATL, however, possesses a secret weapon that no startup in Silicon Valley can match, which is an existing global manufacturing infrastructure that operates at a scale beyond human comprehension. While others were writing white papers, CATL was perfecting the art of high-speed coding and precision assembly in factories that produce more energy storage in a week than most countries use in a year. They have taken the lessons learned from building the blade battery and other high-density chemistries, and applied them to a proprietary manufacturing process that allows for the mass production of solid-state cells without the astronomical costs that have traditionally killed this technology. This is the moment where the lab experiment becomes a commodity. And it is the reason why the traditional automotive giants are suddenly terrified, because CATL isn't just selling a dream, they are selling a supply chain. When a company like CATL moves into a new technology, they don't just build a factory, they secure the entire vertical integration from the lithium mines to the chemical processing plants and the logistics networks that span continents. This means that when their solid-state battery hits the market, it won't be a luxury feature reserved for million-dollar hypercars, but a standardized component designed to fit into the next generation of family SUVs and urban commuters. The genius of CATL's approach lies in their business-first mindset, where they recognize that the world cannot wait for a perfect solid-state battery that takes 30 years to develop, so they have focused on a transitionary architecture that provides 90% of the benefits today while others are still chasing the final 10% in a lab. This pragmatic industrialism is what separates the winners from the dreamers in the EV race, and it is why experts are now saying that the solid-state era has officially moved from a maybe to an any-day now reality. The sheer physical density of these new cells means that a car designer is no longer constrained by the massive rectangular slab that currently sits at the bottom of every EV, and this freedom of design will lead to vehicles that are more aerodynamic, lighter, and far more efficient than anything we have seen since the invention of the wheel. We are talking about a total decoupling of the car's weight from its range, where you can finally have a small, nimble sports car that can still travel 1,000 kilometers on a single charge without carrying a half-ton battery pack. This is the end of the compromise era of electric vehicles, and the beginning of a period where the electric motor finally achieves its true potential as the most efficient way to move humans across the planet. The silence from Tesla and BYD is not a sign of indifference but a sign of intense internal pressure as they realize that the primary advantage they held, their manufacturing lead in traditional cells, is being bypassed by a superior technology that they do not yet control. The industrial gatekeeper has changed, and as CATL prepares to flip the switch on their mass production lines, the entire world is about to find out what happens when a laboratory miracle meets a manufacturing empire. This is the moment where the skeptics are silenced and the true scale of the electric revolution is finally revealed to the public, not through a flashy keynote speech, but through the arrival of cars that simply do not have the weaknesses we have been told to accept as normal. The transition is no longer a distant hope, it is a commercial inevitability, and the revelation of how this will crash the market for petrol cars is the final piece of the story that will keep you watching until the very last second. The silence emanating from the headquarters of the world's automotive giants is not merely a lack of news, but a profound and heavy admission of an industry-wide power shift that is no longer a theoretical projection, but an imminent commercial reality that will fundamentally alter the global economy. For years, the narrative of the electric vehicle was one of optimistic slogans and incremental improvements, where pioneers like Tesla and BYD operated with the untouchable confidence of kings who had mastered the liquid electrolyte lithium-ion battery and built massive gigafactories to defend that legacy. However, the arrival of CATL's solid-state and condensed matter technology has effectively acted as a technological ambush that has bypassed the traditional defenses of the current industry leaders and created what many historians will soon call the Kodak moment for the internal combustion engine and any company too slow to abandon it. As we stand deep in 2026, the technological ceiling that once capped the performance of electric cars has been shattered by CATL's deployment of condensed matter cells, boasting an unprecedented energy density of 500 Wh/kg, which is a figure so revolutionary that it has already begun to migrate from high-end luxury vehicles into the world of electric aviation. This isn't just a minor upgrade or a marketing gimmick, but a total doubling of the energy storage capacity found in the standard high-nickel batteries of just a few years ago, which means the physics of the market have been permanently rewritten. While the rest of the industry was caught in a circular debate about whether a 1,000-kilometer range was even a necessity for the average driver, CATL was busy securing the supply chains and manufacturing patents to make that range a standard feature rather than an expensive luxury. This is the moment where the petrol car's last standing fortress, which was the convenience of the long-haul journey and the speed of the refueling stop, is being systematically dismantled piece by piece. Imagine the psychological shift that occurs in the global consumer mind when it becomes common knowledge that an electric vehicle can now outlast a full tank of premium gasoline and then recharge its massive energy reserves in less time than it takes to order and finish a cup of coffee. This is the existential crisis that has forced companies like BYD to scramble with their second-generation blade battery and ultra-fast charging protocols, but the underlying tension remains centered on a single uncomfortable question. Can a liquid-based chemical system ever truly compete with the intrinsic safety, stability, and thermal resilience of a solid-state core? The answer is being written in the frantic redesigns and emergency boardroom meetings where CEOs are realizing that their multi-billion-dollar investments in traditional battery production lines might soon become stranded assets in a world that has suddenly moved on to a superior architecture. Even Tesla, which for a decade was the undisputed North Star of innovation, is now finding itself in the uncharacteristic position of playing catch-up as CATL sets the global roadmap for mass-produced semi-solid batteries and moves toward a full all-solid-state production target. The real revelation that is currently shaking the foundations of the global market lies in the sheer scale of the economic subversion that CATL is executing behind the scenes by attacking the traditional engine from both ends of the spectrum simultaneously. They are not just creating high-end batteries for million-dollar hypercars, but are integrating their extreme longevity sodium-ion and solid-state hybrids into the most affordable commuter vehicles on the planet. We are witnessing the birth of a power cell that can theoretically last for over 5 million kilometers, which is a lifespan so vast that it outlasts the physical structure of the car itself and even the driving life of the person behind the wheel. When a battery transitions from being a degrading chemical liability into a permanent lifetime asset, the entire concept of vehicle ownership and resale value is transformed into something unrecognizable to the current market. The petrol engine, with its thousands of vibrating parts, its inherent waste of thermal energy, and its dangerous reliance on a volatile and politically sensitive global oil supply, is beginning to look like a primitive steam engine in the age of the supersonic jet. This is why the uncomfortable feeling felt by traditional manufacturers has escalated into a full-scale panic, because the technological gap has not just closed but has inverted in favor of those who control the solid-state laboratory. The barrier to mass adoption has not just fallen, it has been obliterated by a company that understood that the future of the world isn't built by those who design the curves of the sheet metal, but by those who master the microscopic movement of the electron. As we move into the second half of this decade, the question is no longer if electric vehicles will dominate the global landscape, but which of the historic automotive legends will possess the agility to survive the transition and which will be relegated to the museums of the Industrial Revolution. The final piece of this puzzle is the realization that the era of compromise is dead and the era of the solid-state titan has officially begun, leaving the world of internal combustion to fade into the shadows of history as a noisy and inefficient relic of a simpler time. The revelation of CATL's true production capacity is the final signal that the global energy war has already been won, and the rest of the industry is simply waiting for the news to reach the public.